had to rewrite each of the following as an equivalent expression with a single exponent. So table one, what did you get when it was 2 to the 4th power times 2 to the 0 power? Done this before, I mentioned it earlier. Decided to not take out your notes, like I don't know, but when I have exponents on the same base, what do I do with the exponents? Table one. You add them, so then when we rewrite this, what should it be? Can you tell me what the exponents are? And what's 4 plus 0? So then when you rewrite it, it should be, that's it. That is all. We've done it before. And it's the same rule that we've used before. That's called the product rule for exponents. If you don't remember it, don't have your notes out, maybe rewrite it on the side. If I have bases that are the same, so like the 2 would be the base, and the bases are being multiplied together, you can add the exponents. So same base, 4 plus 0 is 4. You could have probably told me what 2 to the 4th power is in your calculator, but that's not necessarily what it wanted. It wanted you to rewrite it. So now apply that rule to the rest, same rule. So table 2, what about 2 to the 4th power times 2 to the negative 1? What is it written on? Would this be the same base? So according to this rule, what do I do with the exponents? So 4 plus negative 1 is you just put that away from me.
It's
Yeah, but some people need a calculator. Okay, but 2 to the 3rd is correct for this one. So table 2, I'll give you another one. No one take it away from me this time. Table 2, 2 to the 4th times 2 to the negative 3, what would it be rewritten? Okay? Anyone disagree with that? Yeah?
obviously.
Okay, it's not obvious to everyone. But everyone should be able to get the right answer because you all have access to a calculator. So like, I totally understand negative numbers can be confusing, or maybe we just forget sometimes. But I'm not your middle school teacher. I'm not gonna spend time making sure you know your times tables. I'm gonna hand you a calculator because that's what happens in the real world. You will never have a job where you can't use a calculator. So anyway, yeah, so simple mistake, maybe we just didn't see the negative, but we could see how they got to that mistake. It should be 2 to the 1st power rewritten with a single exponent. How else can we write 2 to the 1st power though?
2.
Just 2. But that technically doesn't answer this prompt. It wanted it with a single exponent. But just know if the exponent's not written, it's always 1. Not 0, otherwise we put a 0 there. So then table 2, I'll give you a shot for reading yourself. 2 to the 4th times 2 to the negative 4. The exponents 4 plus negative 4. I have $4 and I take $4 away. 0. So 2 to the 0 is how you rewrite the last one. And anything to the 0 power can also be written as what? Not 2. Anything to the 0 power always equals what? You test it out on your calculator. 1. Again, that really wouldn't answer this prompt. It wants you to rewrite it with a single exponent. So really it should be 2 to the 0 for this. Ordinarily, you simplify it. Questions on that? Okay, so if you didn't know, now you know. Not a big deal. We can move on now. But one thing I will add to this lesson, if you look on the board, it's called using negative exponents. It is a rule that if you have a negative exponent in your final answer, you are supposed to rewrite it. So like we didn't happen to get one in our final answer, but say that the problem was 2 to the -8 times 2 to the 4th. Table 3, what would it be written as? What do you do when they have the same base? The exponents, yes, and then -8 plus 4 is -4. Okay, so here's an example of when we do have a negative exponent in our answer. You could put this in the calculator and get what it actually equals. Or you can apply the negative exponent rule, which technically you're supposed to if you have an answer with a negative exponent. And probably write this down. I don't know if it's on your chart from the other day, but it is a rule. And especially in algebra 3-4, you will have to apply this rule. We don't do too much of it. But it says that if I have a negative exponent, it can be rewritten as this. So where x and n can be any number, it'd be rewritten like this. So the way that I'll tell my students to think about it, if you have a negative exponent in your answer, if it's not already a fraction, but a fraction mark, any numbers that have a negative exponent attached to them basically go across the fraction. And just like how there's normally a 1 here, if it's not written, like all whole numbers are over 1, like there's still a 1 there. It's just that now this goes underneath the fraction bar, rewritten as positive, like how this is. And if there's nothing else from before, then it's just a 1 kind of flips. But they give you the same answer, so that's what's important. And you'll see why once we do the rest of the lesson. It's just more proper to not have negative exponents in your answer. So 2 to the -4th power is equal to that decimal. And so is 1 over 2 to the 4th power. They're equivalent. Questions, comments, concerns? Okay. Briefly, let me tell you the goal today. We are looking more closely at exponential graphs and equations. So a lot of repetition, I told you. That's why this is actually probably my favorite unit all year, because I feel like it makes so much sense. You do the same thing almost every single day. So by the end of this lesson, you'll be able to describe the meaning of a negative exponent in equations that represent exponential decay, and write and graph an equation that represents exponential decay to solve problems. I record all the time, linked in there if you ever want to work ahead from last year. Puzzle piece is lesson 7. we don't have an assessment this week, but Monday, be ready to take a quiz on everything we've covered this week and from last Friday. Just have your notes all up to date so you can use them for the quiz. And even though we're not testing until February 8th for Unit 5, don't wait till that day to get all your missing assignments done. I've been updating them almost every day. You don't necessarily need to email me when you get something done. I don't drop everything I'm doing to update it. But it's always within 7 days. The only students that ever have to message me sometimes are like my math lab students for math lab things. So like algebra, it auto updates when I press a button every few days. So questions? Okay. So first activity. Coral in the sea. A marine biologist estimates that a structure of coral has a volume of 1,200 cubic centimeters and that its volume doubles each year. You're going to write an equation in the form y equals a times b to the t, representing the relationship, where t is time in years since the coral was measured, and y is volume of coral in cubic centimeters. So you have to figure out what a and b are in this equation. Do that briefly before you try number 2. It would be plugging into the equation, but in your groups, remember what A and B was. We definitely talked about it before. Look in your notes if you don't remember, but that's your first task. So we'll give you about a minute to do that. Rule 4, can you tell me what A is going to be in this situation? All the information you need is here, and then you just need to rely on your knowledge of it is 1,200. Because A stands for what in exponential functions class? Your starting amount. So whatever situation they give you, I mean, they usually tell you what you're solving for. We're solving for the amount of coral in P years. So how much coral did I start with? 1,200. So there's that, starting amount of A. Table 5, what's going to be my B in this situation? It doubles each year, which means multiplying by what? So B is going to be 2. Good. Questions on that? Does anyone know what the formal name for the B is? Common factor. So whatever you're having to multiply by each time to get to the next number. From year to year, it's doubling, so I'm timesing by 2. So is it increasing or decreasing? Table 6. Doubling each year. Increasing. So this would be exponential growth. Because the number with the exponent is bigger than 1. So it should increase over time. Good. So that's how you set it up. You read it, know what A is supposed to represent, know what B is supposed to represent, and set it up. Now you guys should be able to answer number 2, which is find the volume of the coral when T is 5, 1, 0, -1, and -2. Consider making a table of values. P would be your input, U would be kind of your input, Y would be how much coral I have at that time. And it said when T is 5, 1, 0, -1, and -2. So if you're not reading the answer off the calculator screen, I mean, I guess there is a way you can get it other ways, but if you're not reading it off the calculator screen, then I'm not confident that you will do well on these assessments. Everyone needs to practice this calculation. So table 7, when T is 5, what did you get for the output? 38,400. If you got something different on your calculator, then you need to ask me to look at it, or someone at your table maybe might know. Because that just means you made a calculator. And that's an easy fix. So it should say 38,400 when the exponent is 5. Now, table 8, when the exponent is 1, what's my output? 2,400. Let's think about it. 2 to the first power is just 2. 2 times 1,200 is 2,400. Or that's 1,000. Table 9. What about when t is 0? 1,200. It will tell you that in the calculator, but also you should know that whenever the t is 0, that's your starting amount, right? We already addressed that. 7,500. Table 1, when t is -1, what's the output? 600. And table 2, when t is -2, what's the output? Good. Now for this, notice we've already said it's growth. The numbers increase over time, but when we go to negative time, the numbers get smaller. All right, if I put it from smallest t or greatest t, it'll look more like the numbers are getting bigger. So just like try not to let the test trick you because it is still growing over time. So good. Side note, if you don't know how to put that in your calculator, make sure you pull me aside at some point. So you can fix whatever all you're doing is change the t. Now for what does it mean when t is -2? So that I'll give you a minute to discuss with your groups and to figure out in what year the volume of the coral was 37.5 cubic centimeters. So what does it mean when t is -2? And the volume, or the year that the volume was 37.5. Okay, table 3, when t is -2, what does that mean? Do we normally have negative times? So I'm trying to walk you there, so kind of hear what I'm saying. Do we ever really have negative hours? So if you reread the situation for what t represents. What does it mean when we say -2 hours? For this situation? 2 years before what? So 2 years before they started measuring the coral. Because we said their starting amount was 1,200. So then if we're not before we're t is 0, that would be 2 years before, because it's 2 years. It could be hours, it could be days, but in this situation, it's years. So 2 years before they started in cubic measuring. So say, and it didn't tell you what year. So like, say they started measuring in the year 2000. 2 years prior would be in 1998. So you can still get values, it's just depends on where they started measuring. Good. Table 4. Did you find the year that the volume is 37.5? So Are we solving for the t or the y? Table 4. We're answering number 4, but you didn't tell me anything, so now we're taking it as a step. So are we solving for a t or are we solving for a y? Incorrect, you're solving for a t. Because it says in a certain year, the volume was this, which year? So we're solving for which year the y was 37.5. Now, we have a few options. But one of the options I don't think you'll do until you get to algebra 3-4, because I've not taught you logarithms and I don't need to teach you logarithms. You could try plugging this in for y and solving for t, but you won't really know how to do that. So what I would recommend is continue the pattern until you find what year it should be. So we want to find when it's 37.5. So should I add numbers that are greater than 5 or smaller than -2? Table 4. So we're solving for when y is 37.5. We have some y's here. You won't be able to just plug in y and solve for t, like you just won't. Unless you have a graph. So we want to know when y is 37.5. Should I continue the pattern where t is values that are bigger than 5? Or where t are values that are smaller than -2? Smaller than -2. So maybe I'll test like -3, -4, -5, until I get to where it's 37.5. All right, you have the equation, or you could continue the pattern, it's up to you. But I'll do the equation because I haven't shown you that on the calculator yet today. So 1200 times 2 to the -3 power is not 37.5. So I'm going to test a smaller number, but it's getting closer. So then when t is -4, it's 75. Still not what I'm looking for. When t is -5, now I have the answer I'm looking for. So in what year was it that the coral was 37.5? Five years before they started measuring. They didn't say what year they started measuring. So you'll just say when t is -5, or you could say 5 years before they started. Good? And also notice, like, if I was going year by year, it was doubling, like it was timesing by 2. When I'm having to work backwards, I'm not timesing by 2 anymore. I'm timesing by 1/2 when I was working backwards. But we had the equation, so that's good. Questions on that? All right, I mentioned if you had a graph, you could probably find the answer without just having to like guess and check or continue the pattern. So here's how you could type it into Desmos and it give you a graph. T would normally be on the X or Y axis. Time would normally be on the X or Y axis. That should be a really fast answer, like we talk about it all the time. On the X axis, thank you. Notice like Desmos doesn't read T's. If I put in a T, I don't see a graph. But since time normally goes on the X axis, make it an X, now you can see a graph. It's a little hard for some of the inputs that we came up with to see. So that's where, like, on your paper, it says something about windows of graphs. I'll just kind of briefly tell you instead of doing that activity. If I want to see for like when t is 1, like I'm having a hard time because 1 is somewhere over here and I can't see my line. Depending on what calculator you have, like if you have your own graphing calculator, Google how to adjust the window on that one. For Desmos, you hit this little wrench, and then it has like parameters for your X and Y axis. So if my X's go from like -5 to +5, then I'll probably pick some X's near that. So like, I don't know, -8 and +8, so I can see it better. For the Y's, they went from 38,400 down to like 37.5. So somewhere close to that. I can make the lower threshold 0, the upper threshold like higher than my biggest value. And now when I look at the graph, I can actually read it. So like at year 2, it was 4,800. At year 1, it was 2,400. So it could solve some problems like that if you know how to fix the window. Yes? Which one? All right, so there's that. Just FYI, in case you want to use the graph, that's how you can use Desmos. Highly recommend you still get your own graphing calculator because you don't get Desmos on your state test for 9th grade. This next question on the back will be kind of like your check for understanding, where it says measuring meds. It's really similar to what we just did. You're going to make the equation based on the situation, identify what A and B should be. Answer for when t is -1 and -3, add it to the table. And sketch a graph. That's like, I guess, the only thing that's different. But sketch a graph on this blank one that you have down here based on what your table of values would say. Questions on that? And also explaining what t equals 0 and t equals -3 mean in this situation. This is all great review for what we do on these tests. And we just did a problem similar. To do that, I'll give you about 5, maybe 6 minutes to play around with all of that. And when and if you finish early, you can open up your practice and get started. But we will go over this in about 5 or 6 minutes. All right, a person took some medicine but does not remember how much. Concerned that she took too much, she has a blood test every hour for several hours. Time t is measured in hours since the blood test, and amount of medicine in her body M is measured in milligrams. What's the growth factor, meaning like what's B in this equation, and then what is A? Let's start with A. I feel like that's the easier one, in my opinion. Table 1, what's A gonna be in that situation? 100. Because that's my starting amount. If t was when she took the blood test, then t equals 0 would be like the start of it, right? So any hour after that is since she took it. Also, side note, if you want to think of A as your y-intercept, that's usually your starting amount anyway. By definition, your y-intercept is whenever x is 0. So when t is 0, that's my y-intercept. And A for this dimension. Now my growth factor, so what would I have to multiply each time to get to the next number? Table 5, what do you get for that one? 0.5. Anyone disagree with that? And let's see if that's true. What's 0.5 times 100? 50. What's 50 times 0.5? 25. So yes, that is my factor. Good job. A lot of people would say that it's 2. Because I don't know, they see that a pattern is, I don't know, timesing by 2 if we go backwards, which is what we have to do, like to go backwards, like I'll give you that. But to continue the pattern forwards is like what we're looking for. People also told me the pattern's dividing by 2, which is true. But factor is something you multiply. So B has to be what I can multiply by to get to the next number. So yes, dividing by 2 is the same as multiplying by 1/2. It really is. And then to continue the pattern backwards, you do the opposite. So there's that. That's the equation you use to solve for when t is -1 and for when t is -3. If you put -1 first, that's fine, but like in the future, it'd probably be better to do it from smallest to largest in the table. But it really doesn't make a difference right now if you put that. When t is -1, what's my output? Table 8, you're on deck for that one. Miss Medina. So table 8, when t is -1, what's my output? $200. Because if it's halving each time as we go forward, 1 hour before would be double. So it's kind of like the opposite, I guess. You're working backwards. Or just put in your calculator and it'll tell you. 200 when the exponent is -1. Table 6, when the exponent is -3, how much medicine does she have in her bloodstream? 800. So if you were continuing the pattern in the table, know that it skipped -2. So for -2, it would be 400. For -3 is 8. Good. Use the calculator, do what you gotta do, get the right answer at the end of the day. What does it mean when t is 0 in this situation? My next question will be, what does it mean when t is -3? So when t is 0, I'll take a volunteer. So 0 hours since she did the blood test. But good to remember, she doesn't really remember how much medicine she took. So, if you reread that, t is measured in hours since the blood test. So when she took the blood test. Initially. So then if that's the case, when t is -3, what does that mean in this situation?
Before she took it,
And how much before she took it?
3 hours before.
Good. 3 hours before the first blood test. That will show up on your final too. Interpret t equals -3. I'll say that. It could be weeks, days, this time it's hours, so it's 3 hours before, since it's negative. Lastly, the graph you were supposed to sketch. So now that we've confirmed all the right X's and Y's, like this isn't labeled, so you would have to decide how to label it. My X's go from -3 to +2, so I could just count by ones down here. I didn't label the -2, but that's fine. And then my biggest Y value is 800. My smallest is 25. So just pick something that is consistent. It's such a small graph, so I'll just do by 500s and we'll just put it where it would approximately be. And you can use a calculator for that I mentioned, but we also have the table of values too. So when t is -3, it would be at the 800, which would probably be like around there. We're just going to estimate it. When t is -1, it's at 200, so probably like somewhere here. We can include the -2 at 400 if you want. At 1, it's at, or at 0, it's at 100, so that would be your y-intercept. At 1, it's at 50, so even smaller than that for the y. And at 2, it's at 25. So is it increasing or decreasing over time? Decreasing, like read it left or right, like how you read a book. Decreasing over time. So this is exponential growth or exponential decay? Perfect. You hit all the main points that you'll be tested on so far. Question? All right, you have a puzzle piece in Schoology. Lesson 7 is the one we just did, but really they should all be done up to this point. So that's what you should work on, not just packing up and sitting with a blank desk. But it's the